Hey guys, so moving on from the last video where we sort of like did our Topo Struck 3D Millipede workflow again to work out a optimal volume in which that would support this concrete slab geometry on these 3 points, right? And we could optimize this until the cows don't come over if we wanted to. Like we could bump the iterations up or make the resolution a lot better so we get a really nice looking mesh. But I kind of think this is pretty cool by itself. And just to make ourselves come to the realization that we're doing generative design right now. So just let that sink in for a little bit. Long story short, generative design is a wanky term that the devil Autodesk has made popular again to surprise sell more software. But we're doing it. So sick, and the best thing is we're doing it in Millipede, which has been free. Been around for ages. Who knows? It's hard to find now. They might have been bought out by Autodesk, but we haven't given them any money, which is great. Cool. So there's that rant over. Remember to smash that like button if you agree. Hit dislike if you like Autodesk. See how that one goes. But anyway, let's actually have a look at this mesh that's come out. Right. I'll just drop the panel down quickly. Cool. It's this Michael Pryor, who made Pufferfish up here. Is this beautiful selection of components, do a whole bunch of things. Has is mesh closed component, which will tell you if the mesh is open or closed. It's currently false, so it might look closed, but it's not. So what we're going to do is we're going to fix this so that we can so we don't just, we're going to start to, in the next couple of videos, we're going to generate a structure within this mesh. It's going to be a real shit structure, but it's going to be structured nonetheless. So the idea is we'll use generative design, topological optimization to work out an optimal form, and like load path, or whatever you call it, optimal sort of shape of form, and then we'll populate this mesh with a structure to actually represent it, because this is just an amorphous blob. And sure, we can robotically 3D print it, but when you can robotically 3D print anything, like how much of a designer are you, and how much are you reliant on robotic 3D printing? So we're going to bring back down to earth a little bit. In order to do that, we need a closed mesh. So our good friend, who I've never met in my life but would love to, Michael Pryor, has a rebuild mesh component as well, which fixes invalid or shit meshes. We have a shit mesh right now. Usually what I do is I'd bake that into Rhino and maybe go check mesh and repair it. That may or may not work, or I might even put it into like an Autodesk tool called NetFab online. It's great at fixing meshes for 3D printing. I'm just going to use this tool, because at the same time we don't want to break our parametric workflow. We want to be able to like keep it going. So like if we get a shit mesh out of here, we want to like be able to fix it on the fly and not have to wait for any exporting or anything like that. Rebuild normals, we'll do true. So that's beforehand, and let's have a look at it afterwards. Bang, bang. What do we do? We probably don't need that one actually. What else are we doing? Cull, unused, vertices and faces for mesh. I think this might be it. Oh no. Merge duplicate mesh vertices. Yeah, we want to do that. Fix inconsistencies in the mesh vertex and face normals. Yes. Reverse. Do we want to do that? Yeah. And then what's this one? Weld vertices. Yep. Oh. And we're still reading false. There we go. Why might that be? I know why it might be. So what we're going to do is, let's see if we can get this to close. Weld. I'm just going to put this through a bunch of like parametric sort of mesh fixing operations now. So we're going to weld it. We're going to like hide some of those. And anyone who's really good at mesh geometry, don't watch what I'm about to do right now. But it will work, hopefully. So we're going to deconstruct the mesh. And I'm going to construct mesh again. And let's have a look what that does. Oh, look at that. Has it fixed it? Yes, it has. So I just want to try something real quickly. What if I just did this? No. So we have to do a few fixes first, but you know, we get there in the end. Closed mesh. A closed mesh. It's been, you know, everything's been fixed. And the good thing is, I don't think it cost me like barely any computational time, like 23 milliseconds. That's fine. And at the end of the day, if we take a step back, let's like actually document this a bit better. Group scribble mesh fix, make that nice and large. Cool. And then we'll group. What do we call this? Generative design. Chuck that there. So with our generative design, right, we're probably gonna like do a bunch of iterative optimizations within Millipede itself. Once it gets to here, all right, it's probably not going to change that much. So again, it's good to have this parametric, but might not be necessarily the end of the world. So we'll leave it there. So guys, we've fixed our mesh. In the next video, we'll start to look at how we might make a structure within the mesh. So yeah, see you soon.